Alright, as you can see here, we have boron and nitrogen. I didn't write it there, but you can tell by how many plus signs there are. We have boron and nitrogen bonding ionically, and the way this works is that, as you can see, boron has 3 in its outer ring, and nitrogen has 5. And what you want to have is you want to have 8 in your outer ring, or you want to have 0. So, what is going to happen is that boron is going to take its electrons and since it sees nitrogen, it's just going to take its electrons and give it to nitrogen. So nitrogen now has, so that gives boron 0 electrons and nitrogen 8, therefore making them normal gases, which is what they want to do. Now, this may sound confusing, so we're going to try this with two completely different atoms. So here on the left side, we'll take lithium, so we'll have 3 here, and then 1, 2, 3, and we'll take let's say fluorine. So this is gonna have to be a bit bigger. Fluorine is going to have 9, so we'll have to draw 9 in this circle, and it's gonna take a while because I have to draw it now. And now we're gonna have to make the circle, add the 2, and then we're gonna have to make another circle, and we're gonna have to add 7 and stuff. And yeah, okay. Alright, so as you can see here, lithium has 1 in its outer shell, and fluorine has 7. And since lithium is giving away its electron, it is giving it to fluorine, therefore making itself a noble gas because it has 0, and then also making fluorine a normal gas because now fluorine has 8. And fluorine's all happy because it has 8, and now it's also a normal gas. Am I right, Zivia?
Yep.
Alright. And also, she's not part of my group, I just did that. Anyway, so, now we're going to have to go into some more detail about this bond that atoms now have. Now, it's quite a simple bond because we've already gone over this multiple times. Now, as you can see here, as I recover the shell of this lithium, lithium now has lost an electron. So, it gets +1 because now it has 1 more proton than an electron. And now fluorine is a -1 because now it has more electrons than protons. And since lithium is now positive and fluorine is now negative, they will attract to each other. And yeah, same with the nitrogen and boron before. Boron would now become a -3, and boron would become a +3 because it just lost 3 electrons, and nitrogen would become a -3 because it gained 3 electrons. Therefore, the balance is now tipped by whether or not they lost or gained the electron. So basically, ionic bonding is every atom with 1 through 3 valence electrons will give it away and become positive. Any atom with 4 to 7 valence electrons will take the electrons from the groups of 1 through 3 and become negative. And since they become positive and or negative, because they're going to be like right next to each other, they will make a bond through positive and negative charges, which they just gained. So we just talked about ionic bonding. Ionic bonding. Now, we have to talk about covalent bonding, which is much more, well actually, no, it's not more complicated, it's just kind of hard to wrap your head around. So, covalent bonding, it really only works for groups that have 4 to 7 electrons, because everyone wants to gain, so it's just 2 atoms that are like that. So, and hydrogen, but that's because hydrogen's weird. So, first, we'll go with a very simple one. So, we'll go with fluorine and hydrogen. Now, they both have a bonding number of 1, which means they only have to bond to one person, and it will help with the bonding. So, they just have a bond here, and that's it. All said and done. Now, say we need to do a more complicated one. Say we have to do something like fluorine, oxygen, nitrogen. Yeah, I think no, nitrogen doesn't work. Hold on. Let me think of one. So actually, no. If we did oxygen, nitrogen, and oxygen. Oxygen has a bonding number of 2, where nitrogen has 3. So you're probably wondering, how do I make sure, oh wait, this doesn't work. Oh wait, I think if we had 2 nitrogens, okay. So if I were wondering, how could we have all 3 of these bond evenly? Well, oxygen only gets bonding number 2, so you bond these 2 together. But that doesn't work. Nitrogen has a bonding number 3. You've only bonded these 2 once. So what you do, you bond each other nitrogens. But that still doesn't work. You need a bonding number of 3 for them to work together. So what do? You double bond. That way, everyone has bonded it evenly, and it all works. So, what have we learned today as soon as I can erase this? We have learned that covalent bonding is rare. Everyone has 4 or more electrons bond together by different means, which would just be sharing the electron together, and therefore it works. So if you see a O equal O, then yes, it could be a math problem, or it could be oxygen double bonding with itself.